And welcome to the session. My name is Philippe Ozil. I'm a senior developer evangelist at Salesforce, and I'm here today to talk to you about event-driven software architecture with platform events. This is a developer session, so I will be showing some code just to warn you ahead, and I'll be talking about architecture as well. Before I get started, I'll have to give you the traditional forward-looking statement. Because we are a publicly traded company, please do not make any purchasing decisions based on what I'm going to show in this presentation. All of what I'm going to show not only should be already available, some of the features are in Winter 18, but no big surprise. So what's our agenda today? The agenda today is twofold. First, I'm going to talk about event-driven architecture, outside of the context of Salesforce, just general event-driven architecture. And then I'm going to jump into something that is more Salesforce related, that's platform events. And I'll be showing a demo of platform events as well. Let's start with event-driven software architecture. So what is an event-driven software architecture? As its name implies, it's something that has to do with events. Now, the interesting part about event-driven architecture is that it's real-time. The events that we are sending to different subscribers and receivers are being sent in real time, so this is something that allows us to scale. Another interesting part of this model is that it's something called a one-way fire and forget mode. To be able to scale, events are being sent without any guarantee of being received by anyone. So this is going to be a full broadcast mode with no reply happening. And the technical way to describe this is called a publisher-subscriber model, and I will explain that with a diagram just after. Two main advantages of using this kind of system. First, it scales. It's something that can grow with enormous amount of data. And it's also something that works with decoupling, meaning that when you have different endpoints that communicate with each other, they don't need to know about each other. It's functioning in some sort of black box mode. So I mentioned publisher-subscriber mode, and this is the way it works. In the middle of the architecture, there's something called the event bus. The event bus is something that will carry all of our messages. This event bus is actually segmented in something called channels, which contain different messages. And you have event consumers. Event consumers are bits of applications or different endpoints which are interested into receiving specific messages. So the different event consumers are subscribing to messages that are on the event bus. They're subscribing to a specific channel. A channel can be, is an order processed? Do I have a new customer? So the consumers are the first to act. They will register to a specific topic or channel on the event bus. Then we got something called the event producer. This is the part which will send the actual event, and it will publish the event. So in this presentation and in general literature, you'll hear about events, but you'll also hear about messages. This is the same thing. And so these messages go from producer to consumers, but the interesting fact here is that the producers do not know the consumers. So producers will publish their messages, but they only know the event bus. They will not know the lower tier of this diagram. They will not know about consumers. They will have no guarantee that their messages are being delivered. They will only know that the message were published to the event bus. And after that, it's the matter of the event bus to broadcast the messages back to all the registered consumers. So how does this compare to a traditional request-driven or service-oriented architecture? So this is a diagram, an example I took online from a shop, so it's an e-commerce solution, really basic. And the idea is that it's decoupled into several services. All of these services rely on each other. They have interdependencies. For example, the customer database is the central element in this architecture. The shop, the payment, newsletter, and reporting services all rely on the customer database. They all have tight coupling with this particular service. Now, what happens in this kind of architecture is if we need to change one of the APIs that this customer database service exposes, there's going to be something called a ripple effect. So, for example, if I want to deploy a new customer database that exposes new API, version 2, for example, I'm going to impact all the links to this service. So the shop, the payment, newsletter, and reporting are going to be impacted. And in turn, I'll need to update all of these services because they're tightly coupled. So that's the problem with request-driven or service-oriented architecture. With event-driven architecture, we no longer have this problem. Why? Because the event bus here acts as a decoupling factor. It helps us to not have those interdependencies. There's a separation of concern between the different services. The shop service only needs to know about shopping. The payment service only knows about payment. And what they do afterwards is that they send events to the event bus, and they don't need to care about the implementation of the other services. So if you want to replace one of those services, you just have to change the individual service and not the entire architecture. Let's see an example at work. Here, I've taken the services you saw before, and I'm going to show you an example by having an order event. So for example, the shop will issue an order event, and what happens after that is there's the broadcast to all recipients, all the services that are interested in this particular event. And you see that this happens in twofold. The event is published, and then the subscribers get the event. This is how we achieve decoupling. Now, there's an interesting thing that is important to understand is that events are not actions. They are actually the consequence of an action. So it's not, here it's not, this is a new order. No, a new order happened. So this is a bit different. The way we're thinking about it is, it's a gymnastic we need to perform to understand how this works. Now, let's talk about platform events, because most of you here are coming here for the Salesforce Platform talk, so let's talk about Salesforce Platform now. Platform events are something that were introduced in summer 17, and we've been updating it in winter 18, so there are new capabilities. These are already available in winter 18. It's very similar to Streaming API. I don't know, do some of you in the room have used Streaming API before? Yes? So you'll find a lot of similarities between those two things, and I'm going to go down into the details, the specifics, between what is different between the two. But one thing that is common between the Streaming API and Platform Event is that they both rely on a publish-subscribe model. So it's the same common kind of architecture, but there are some little twists. For example, for Platform Events, we get some extra declarative approaches that are not exposed in the Streaming API. And for Platform Events, we also have, of course, the code approach, and I will detail all of those. And then for Platform Events, we have also something that is strongly typed. That's not the case for Streaming APIs. You can type some topics, but the type of the topics are linked to a particular query. And then one thing that is important, be it the Streaming API or the Platform Events, all of these things are never persisted. There's something called a replay window, so it means you can replay an event that happened in the past, but it's only for 24 hours. It's no longer than 24 hours. So by being not persisted, this means that you cannot query for events. There's no way to write SOQL query to fetch the events that happened. And there's also no user interface to display those events inside Salesforce. So there's no special record tab in any user interface. It's up to you to create your own visualization tool, and remember that it's real time. Now let's have a look at the differences between the Platform Events and the Streaming API. So if you're familiar with the Streaming API, you'll recognize there are two types, actually, of events that can happen. There are push topics and generic events. Now, for the data structure, when you're looking at Platform Events, you have custom type field. It's pretty much like a custom object. You can add multiple fields. There are a restricted set of types that are available, but it's pretty flexible. Then for the push topic, you have certain type fields, but it's fixed. These are pre-assigned by the object you're looking at in your SOQL query that defines the push topic. Now for generic, after that, it's just a string. It's a 3,000 character string, which is totally unstructured. So it's up to you to create your own JSON structure, but there's no validation on the actual message content that you're sending. Then for publication, Platform Event is actually the most flexible type of events because you can create those with declarative tools or with code, and I will go more in details in that later. And for push topics, well, you don't have the choice. We're basically looking at record changes, so we're only firing events when the actual records you're looking for are changing. In generic, it's only through code, through REST API. For the propagation, all of these are broadcast, but the generic Streaming API has a special setting which allows us to send an event to specific receivers. That's not something you can do in Platform Events. And lastly, in terms of subscription, Platform Events, again, are very flexible because you can use a user interface to select recipients, or you can also write it with code. While on the Streaming API, we only rely on something called the Bayeux client. It's a library. I will talk more about that also. So let's have a look at the different options for publishing and subscribing platform events. So on one end, we have publishers. These publishers can be classified in two main categories. There's, of course, the Salesforce platform, and there are external apps. And by external apps, I mean it can be Heroku, it could be your own app on your desktop, it could be a mobile app, it could be an IoT device, whatever. Now, depending on which device you're going to use or which platform you're going to use, you'll have different options. So for example, if you're using an external application, you'll have to use platform APIs. You can publish platform events with the SOAP API, REST API, or the bulk APIs. This is true for both external apps and the Salesforce platform. Then, if you're on the Salesforce platform, you can use Apex to create a platform event, or you can also use declarative tools such as Lightning Process Builder or Visual Flow to program it to declaratively create those events. Then let's look at the other way around. Let's now look at subscribers. So for subscribers, it's going to be the same. It can be an external app or the Salesforce platform, and then for each of the different environments, we have, of course, specific restrictions on what can be received. For external apps and Salesforce platform, we can use something called the Bayeux protocol. So this is a protocol that describes the way you can receive events. And here I have listed a couple of implementations. These are JavaScript implementations that allows us to subscribe to platform events, either in external apps or in platform. So this is the code approach for receiving platform events in external apps. Then, for a Salesforce platform, you can write an Apex trigger, which is pretty much like a standard trigger. I will show some code later. And you can also use, since Winter 18, visual tools, so like the Lightning Process Builder and Visual Workflow to start a process or start a flow based on a platform event. So this is the new part from Winter 18. So these are all the endpoints and publishing options you have on the platform right now. I'll leave it for a small second. See some people are taking pictures. All right. So this is something quite rich. We got a lot of options. And I'm going to detail a bit how this works by showing a bit of code. But first, let me talk about the Bayeux protocol. I mentioned this several times. This is something that is not very known, to people using Salesforce because it's a low-level protocol. And so when we are publishing platform events, when the event bus sends message to subscribers, we're using something called the push technology. So that means that the connection is not going is not a bidirectional connection between the client and the server. So the difference of an HTTP connection, the action is started by the server. The server is actually pushing data to the client. It's not the client that is fetching data. And the Bayeux protocol is one of the tools we use to have this push technology. And so the Bayeux protocol is using JSON. So we're sending JSON from the server to the client. And we have two ways to do that. There are two transports, so we say two ways to carry this information. We can either use polling transport or streaming transports. And then for these two categories of transport, we have different implementations that are defined in the protocol. We can have HTTP. So this is, I would say, the least efficient way to do it, but it's something that is supported by most browsers. And we have WebSockets for streaming transport. So the best possible implementation is WebSocket. This is something that is relatively new. It's part of the HTML5 standard, but it's not yet adopted by all browsers. So what Bayeux protocol recommends is that we first try to establish a connection with the WebSocket protocol because it's something that is more efficient. And if the WebSocket protocol is not available, it will fall back to the HTTP protocol. And what polling means is that we're going to continuously request for new messages to the server. So it's something that doesn't scale as well. It's not as performant as streaming. So this is the background behind the technical implementation of the Bayeux protocol. The Bayeux protocol itself is not an implementation. So when you want to use that, you have to define the right library. So there's, again, a couple of libraries that implement this Bayeux protocol. You can use Comet, there's Fay, and WebSocket.io. Plus, there are others. This is a standard protocol, so anybody can implement it. Now, going back to platform events. So I mentioned that platform events are typed. So this is actually creating a platform event is pretty similar to creating a custom object. There's a user interface to do that. And when you create a new event, it's going to be creating something like a custom object with an __e suffix instead of C for custom objects. Then you can add fields to this particular object, and the fields will just be like custom fields on a custom object. Now, I mentioned this earlier also, we are limited to a few basic types. There's no complex type. You cannot have master details relationships, you cannot have pick lists. We're limited to really basic types like text, number, checkbox, date, and time. Why is that? Well, because all of this is going to be converted into JSON, and there is no, it's sending these data outside of Salesforce. So, for example, if you're like having a mobile device, the mobile device will not need to connect to Salesforce to verify the type of the different fields, like the checklist, the pick list, sorry, of these kinds of things. So the general rule is to keep these platform events really lightweight, keep them simple, and only carry the information that you need because you're restricted to these types. Let's now have a look at one of the best practices, the way you exchange with platform events. So you want to send a platform event with an object ID. That's the way you keep this lightweight. You don't copy all of the information of what you need to send. You only keep a reference to the object you want to send. This allows us to have fewer fields in the platform event and make sure it's, the platform event will not change over time. Even if you add custom fields to your object, you'll only have to carry the ID of your object to notify about your change. And then the client can process the event. But what's also need to be added is a double mechanism to query the object afterwards. Because you're not sending all of the fields, what you can do is you can query back from the client to get the entire object or the fields you need from your object, from your platform event. So that's the best way to have an exchange of data between the server and the client. Not send the entire object, only send a reference and then query the object once you receive it. One of the extra reasons why this is interesting is that, remember that the platform event can be sent and received later. That means that there could be possibly a 24-hour gap between the moment the event was sent and the moment the event was received. Because of this replay capability, you need to make sure that when you want to process your event, you're actually looking at data that is up to date. So if you're just skipping the query to the object and you're just processing the event directly after receiving your data, this could be done 24 hours later, and the object maybe has changed in the meantime. So that's a good practice to keep in mind. If you may use replay capabilities, if you want to make sure that you catch events even 24 hours later, make sure that you query back your object to have the latest state. Because once platform events are sent, they cannot be canceled. They're in the queue, they're in the platform, in the event bus, sorry, and you'll receive them when you want to reconnect later. Now let's have a look at a bit of code. I've been talking a lot about theoretical subject. Let's now have a look at the code. So here, this is the way you can create a platform event with code. Notice the underscore at the end of the event. That's the way we define events. And then the rest of the code is really similar to the creation of a custom object. Now, what is the important bit here is this method call here. So we have an abstract class called event bus. That's a reference to our event bus. And we have a publish method, which allows us to publish one event or multiple events. This is the same method, which works for single or a list of events. And then you see that the rest is really similar to a standard object creation. You even have a database save result object to check if your event was sent to the event bus. This does not mean that the event was actually retrieved by a subscriber. It's only meaning that you send the event to the bus, and the bus after that is going to take care of broadcasting it. So even if you have a save result, maybe nobody received your event. Doesn't mean that. And again, I will also emphasize that save result doesn't mean it's saved actually to a database. So this being said, this is the way you send the event. And then for subscribing, again, this is very similar to the standard object creation. You have a trigger that you can create on your on your platform event. In the same way, except we only support the after insert. There is no update. You can never update a platform event. After that, it's really the same code here. So I will not spend too much time on this. REST APIs, well, again, it's very similar to creating a custom object. We're going to do a post on our object, and notice that the object is even stored under the S-object REST API. So there's really nothing specific here between this and a traditional custom object. except you only have posts. You cannot delete them, you cannot list them. Now let's have a look at something more complex now, subscribing to a platform event. So if you're going to write code inside Salesforce, right? So Salesforce, if you want to do that, one of the most easiest way to capture an event is to use Comet. That's one of the libraries that implemented Bayeux protocol. How do you do that? First, you need to configure Comet. Here, we're looking at some JavaScript, which helps us to configure the Comet client. So we are creating the client on the first line. Then we're specifying the endpoint. So this is under Comet and our version number. And we're passing all the information, including our session ID. So this is important. The platform events are secured by default, so they need to have access to your user session ID, because you'll not be able to receive platform events if you're not authenticated. So generally, that means you need to create some sort of authentication mechanism, like a OAuth connected application, to subscribe to platform events if you're using this outside of the Salesforce platform. Then there's also another bit which is interesting. This line is optional, but you need to disable WebSockets to receive platform events. Why is that? Right now, the Salesforce platform does not support WebSocket for the moment. The reason why this is that we haven't secured it correctly for the moment, so we're not opening it yet. This may be subject to change in the future, but for now, if you don't have this line, the first thing the Comet client will do is it will try to establish a secure WebSocket channel with the Salesforce platform. This will not work because we're not opening it yet. And so it will roll back to HTTP. So even without this line, it will still work, but to get a faster connection, you can disable WebSocket directly so that you directly establish the communication with HTTP and long polling. In the future, you won't have to remove this, and we'll be able to have full WebSocket connection. So this is optional. It's up to you if you want to use it or not. Then we really want to establish the connection. So here, we're going to use the settings we set earlier in the configuration to create a connection with the Salesforce platform. So this will check the authentication, it will check our session ID, and it will check also the endpoint we have specified earlier on. Once we have a successful handshake, we have established connection with the event bus, we can now subscribe to different platform events. And here, this is what you will do. You will do a commit.subscribe, specify the name of your event, so it's under /event, then the name of your event, and get a callback to it. And after that, each time you get a new platform event of this particular type in this channel, you'll be able to execute some code. So you can display your event, you can access its properties. This is the high-level view of how you use Comet. It's a few lines, but it's very powerful, and I will show you actually that in the demo at the end. All right. So what are these events used for? One of the first use cases for creating such a system is to use microservices. You'll hear that microservices are really often associated with event-driven architecture. Why is that? Because you have really small services which have no dependencies to each other, they're strongly decoupled. And one of the ways for these microservices to exchange between each other is to use a platform event or an event-driven architecture, because this allows them to be completely decoupled. Another very interesting use case for these platform events is integration. So there are different types of application you can use. So for example, if you're having a Heroku application on the side, a Salesforce platform on the other, and maybe a mobile device, the platform events will ensure that you have this easy to set up integration, because you won't have specific coupling between these two things, the different platforms. Another interesting use case I've just learned recently is also the distributing of processing power. So for example, on the Salesforce platform, you all know that there are some limits. When you do Apex processing, there are some limits. So an interesting way to get rid of those limits is to use a platform limit to offload some of the heavy processing to, for example, an Heroku application or another type of application, and get back the result of your processing. So for example, if you're doing something like image processing, if you're doing something like video processing, or something that is quite power hungry, sorry. You can offload some of the processing power by sending a platform event to your external platform and getting back the results once it's ready. So it's a synchronous way of distributing this processing power. Now, let me get into a demo and show you what we can do with platform events. I'm going to use something called the Northern Trail Outfitters demonstration. So if some of you were here during the Trailhead DX keynote, you may have seen this demonstration. So I'm going to use a winter in Chile environment, and I'm going to show you how we can use platform events to integrate between a Salesforce platform and a Heroku application. So Northern Trail Outfitters is a fictitious outdoor clothing company, and they sell merchandise such as jackets, backpacks, and everything. And what they do is that they create mix of their merchandise to send them to their manufacturing division, so that the manufacturing division creates bundles of these items. So I'm going to create such a bundle right now, and I'm going to show you how the Northern Trail main organization sends this bundle to the manufacturing division. So here I have added a couple of items to my bundle, and notice that there is a path component here that we're going to use it, and we're going to use this to check the status of our mix. So the next step for me now is to actually start a server. I can use a Heroku application that is deployed, or I can even start my own Heroku application on my desktop. That's what I'm going to do right now. So I'm going to open, I'm going to create my own environment here, and I will, here is it. So I'm kicking off a local site on my computer, but I could be also using it on Heroku. And I'm going to show you in real time how the two platforms will communicate. So on localhost 5000. So this is a website for the manufacturing division of Northern Trail Affairs, and they're not running a Salesforce platform, they have their own environment. And what the main branch of the organization does is that once it has assembled a merchandise mix, it moves on to the next step and submits this mix to manufacturing. So I'll just send it to manufacturing, and what happens normally in this, okay, it's not done it. Okay, maybe it wasn't fast enough. Well, yeah, here. Took a bit of time. This is a platform event that shows that we receive our merchandise, and you can see that this is the detail of our merchandise. So the manufacturing division of Northern Trail is able to review the merchandise mix, and once the merchandise mix is reviewed, it can approve it, and it will send it back to the Northern Trail main organization. And you will see that it will move into approved by manufacturing. When I click on approve, it will send another platform event back. Here, you saw that it was moved back to approved by manufacturer. So here I have demonstrated a platform event going from the main Salesforce organization to the Heroku application, and back from Heroku to the Salesforce org. And so what happens behind this org is that there is a Comet D client. There is a platform event that is being registered. Actually, let me just show you that in the user interface. So we have, if I go in setup, we have defined a platform event. And this is, for example, the one that describes that the platform, that the mix has been approved. So we just have a few fields, the confirmation number and the mix ID. So remember, we're using references to our objects. And the Heroku application will be able to query the full details of this mix to get the items, get the quantities. And the way I'm triggering this platform event is actually by running a process builder. So this is something I haven't shown you before, but we have a process behind our mix status change. That's the merchandise mix object. We're listening to a change in the status field. So when the status changes to submitted to manufacturing, we're going to do an action, and this action is creating a platform event. This is the one I showed you, the mix submitted platform event. And we're passing on some references to this platform event. And this will get it to the Heroku application as we saw. So this is an example use case of such an integration. Of course, you can do that on other devices, not just like a computer. You can also do that on a mobile or an IoT device. This is where the full flexibility of platform events is really best expressed because it's real time, so it's very powerful. With that, it's going to be time for me to conclude. So I've shown you today the power of event-driven architecture. I've shown you some main elements like decoupling, like scalability. And I've shown you an example of how we do this on the Salesforce platform, how we use platform events to communicate between different applications, how we use it to integrate with external systems. So right now it's up to you to try it. There are two ways to learn more about platform events. We have created a module on Trailhead which shows theoretical content. And if you want to try it, there's also a project I built myself showing up how you can create an instant notification messaging app on the platform. So this will let you create a Lightning Console application that allows you to send instant messages to other applications. I really suggest that you try it. It's really short. It's just 1 hour. And this will get you enough information to create a small environment and use platform events. With that, I would like to thank you, and I'll be taking questions. Thanks. All right, so I'm going to pass. So can you come please here for the mic? The session is registered, so yeah.
Hi. I am aware that these events have a finite number of calls you can make in a rolling 24-hour period. I was curious if that number is counted exclusively with publishing, or if the number of subscribers will also increase how quickly you consume the limits.
So I'm not aware of a subscriber limit. I'm aware of a number of publishing limits, that's for sure. And there is an option to go high volume. So this is not something I've talked about in my slides, but everybody has access to the basic platform events. And there is an option that for an additional cost, you can get a high volume platform event. So that's something you'll need to discuss with a salesperson. And by talking about high volume, it's like millions. It's something very powerful. So the infrastructure is not the same for high volume. It's based on Kafka, an Apache project that allows us to really scale.
Okay. Thank you.
Sure, welcome.
Quick question. You mentioned that you can't guarantee it's received by the consumer.
Yeah.
Sometimes, obviously, integration goes down or whatever.
Sure.
These processes go down. So if they go down, they don't consume this event. How do they keep track of which replay number that they've got to, or what?
Yeah, so the mechanism is similar to the streaming API. Maybe I should have talked this into my slide. There is basically an ID which is incremental for each message that is being sent in a specific channel or a specific event type. And this ID just keeps on increasing. But if you fail to receive some events because maybe you lost internet connection, your system was down, you can request all of the messages starting from a specific point in time, or you can also ask from a specific message that you last received. So you have up to 24 hours.
So if it's 1, 2, 3, you could say, give me everything greater than 1, 2, 3?
Exactly, yes.
Thank
and
you.
There's also a generic number for saying everything in the last 24 hours.
Thank you.
Yes.
Hi, I had two questions. Did you just say platform events is built off of Kafka?
The high volume, only the high volume version, yes.
Okay. And so you talked about decoupling, which is good, right, and using platform events, and that's why we want to do it, and then sending smaller messages using the object ID. But then you said that the data consumer is querying back into the object. You're coupling now the applications again. So how does that work?
Yeah. So you have two options. If you really don't want to couple, you only can rely on the message itself. But if you need something more real time, you'll have to query back. That's for sure.
But you're going to run into the same problem, right? So
you're going to run into the same problem, but it's only point-to-point integration or dependency. You're not relying on other services. You're only relying on your data structure. So if you take the example of the shop, you had this customer database, you had the reporting, all of the different elements. Mm-hmm. They were all relying between each other. And so here you would only rely on another service, only one, not n services.
So you're going to encapsulate it in another service is what you're saying, so you don't understand the data structure of the data publisher.
Yeah, you only need a reference to the data structure, not to another service. So that's better. Okay. Yes.
I'm trying to figure out how platform events, relate, fit into the overall architecture along with some other options. Like I know you might have an enterprise event bus that you're trying to leverage
exactly
from Salesforce. You might stand up a Kafka instance in something like Heroku.
Yep.
Is that very similar to
It is exactly the same
platform
thing.
events, or
Same
I mean,
concept. It is the
what
same.
What are the trade-offs for using platform events versus, say, Kafka directly?
Platform events are native to the platform, and then again, you get those declarative tools that you could not get for Kafka, for example.
Okay, so it's if you're going to be, for the part of your events that connects directly to Salesforce,
Yes.
platform events are really the way to go,
If
even
you're
if you
gonna
have
use
a
code-
larger
If
bus
you're going to
out
use code,
there.
you can use Kafka for sure directly, but you have to take care of all the administration, the setup, and everything. Here, you just have to define your message structure, and then with a couple of clicks, you can connect with all the things.
Okay, thanks.
Pleasure.
So I have two questions. The first, how many of the different platforms that Salesforce does have support platform events? I mean, are we just talking about the core platform, CRM? Are we talking
No,
about
that's the-
Marketing Cloud, Commerce Cloud, Digital?
You can use the APIs if it's not supported natively, but normally the Salesforce platform is the base foundation of all the different clouds.
And then the second question is persistence. So obviously, there isn't a built-in persistence mechanism other than the replay capability within 24 hours.
Yes.
Does it support JMS queue or other message queue technologies natively or at any point of the process steps so that we can siphon these off and store them in a persistence mechanism that would persist it for longer?
You could easily do that if you just write a small Apex trigger and you offload these messages to another platform. That's something you can do for sure. That's the way you would do it, in fact. If you really want to send it outside Salesforce and you don't want to rely on platform events, when you can write this trigger, which calls, I don't know, a web service or something to create another event on another bus, like a JMS bus or other bus.
Do the IDs persist beyond that 24-hour period? I mean,
Very
like,
incremental,
if you end up making the callback even after the replay is expired.
The only way the IDs are tied to a specific channel, and the only way to change the ID of this particular channel is to change the structure of the message. So for example, if you add another field, it will change the ID of the channel, that's all.
How unique is the ID, the format?
But the ID is not the name, so it's a different thing. Like a Salesforce ID, a long string with a hash.
Yeah, okay, thank you.
Hi, we would like to ask how the governor limiter work in the case that if we have the publisher, you expect for a publisher and then use stringer for subscriber.
Yeah. So the governor limits works in the same way, but there's an extra limit about the number of events you publish. So governor is more for Apex, and then there's also another limit related to the number of events you publish, because you can publish the events with REST APIs, or you can even publish them with the platform builder. So there are two sets of limits.
Is the transaction separate or is the same transaction?
It's inside the same transaction, yes.
Separate one.
No, in
The
transaction.
same one. Thank you so much. Same.
Yes.
Is there any plans to build native support into the Lightning framework for consuming or registering to the
That's a good
Bayeux
question. Not that I'm aware of. Now there's no plan, but it's fairly simple to add this Comet library. Now, with the Lightning Data Service, there are some interesting ways to get those events, because you can write pretty much a generic platform event receiver. That's what actually we do in the demo I showed. Actually, I didn't show it, but in the page we saw in this particular page, there is a component in this page which its sole purpose is to receive platform events, and it's then sending Lightning events on the page. So you can easily write this generic component and reuse it anywhere. It's just a configurable thing. You write down the name of the event you're listening to, and it will send Lightning events to anything in this page. But it's not visual. It's just
Okay. But
hidden
if you have
service
multiple components, they're all going to be
you can create
subscribing
multiple.
to the channel.
Yeah.
Okay, thanks.
For us partners, are events publishable in a managed package, or packageable in a managed package?
That's a good question. I haven't tried that yet, but I do think it's like a custom object, so yes, it should be.
Does that mean, well, okay, so we can't.
There could be a namespace, and yeah, you could be able to package it, yeah.
Okay,
They said in one of the other sessions that you can't package them. Yeah, they did.
all right,
Yeah.
and then,
I assume we do everything so that it's packageable and deployable. Right now, the way we deploy this particular application is with Salesforce DX, so that's something that is already packageable.
okay, thank you.
I just have two questions. So, do we have any governor limits for the platform events?
About what, sorry?
Governor limits.
Yes.
Do we have any governor limits for platform events?
For the Apex part, yes, and there are also some limits for the number of events you can publish in a given time frame. I forgot the number, but it's per 24 hours, there's a limit.
Okay. And how about the concurrency, like two platform events trying to access the same object? So, the concurrency being, I mean, we don't have any issues with concurrency, or it will be a problem?
No, you can have as many as you want. I mean, there's no check between the different platform events.
Okay. Thank you.
Is there a way to use events to get access to something that would not normally be triggerable, such as task contact relationships? When someone assigns a contact to a task, having...
Well, if you create the process behind it, yes, you can do whatever you want. You have full flexibility, I mean.
So what triggers the event in Salesforce that you would put?
Oh, you mean, you have to write the trigger yourself.
Yeah, but if the object isn't triggerable, like a task contact relationship.
I see what you mean.
Can you use events still to...
Well, no, you'll have to figure out a way to detect the change, to trigger it, so no.
Do the events get published at the end of the transaction?
That's a good question. I don't have the answer to this one. I think
so. I guess what I'm asking is, if the transaction fails for some reason, does that event still go out?
Yeah. So it's you have access to this save results. So I guess it's already published before you actually get to the end of the transaction. But I'm afraid I made something wrong. So better check it. Yeah. All right. Thank you. Any other questions? Well, thank you.